This vehicle came in the shop with a dead battery. We replaced it with a new battery, and it came back about a month later with the same problem, another dead battery. So I did a battery test and a few other basic inspections, and at this point, everything checked okay, so I'm starting to suspect there's something else causing this battery to discharge. One of the most common things we think about when we're thinking about parasitic draws is maybe the headlights being left on or a dome light being left on. So I'm going to check things like that, and then I'm going to have a look at all my door courtesy switches to make sure they're operating correctly. And what I'm going to do is watch that indicator on the dash and make sure it goes off when all the doors are shut. So all the bulbs and all the courtesy switches check okay. So I think now it's probably time for a health check. I've hooked up the tech stream, and I don't see any codes stored in any of the body electrical systems. I do have one code for a tire pressure sensor, but I don't think that's going to be related. So I think I'm going to have to do some more research on this vehicle, probably back to the EWD at this point. Well, I've searched TIS and I found a quick training guide called QT611B. It's for the starting and charging system and also parasitic draw tests. So usually step 2 just consists of us flipping switches and checking for other systems that aren't working and things like that. But if I'm looking at this, it looks like it's going to get a little bit more involved at this point. I think we're all familiar with the parasitic draw test, but I want to go over a few of the finer details of that. Current testing is the only time we need to move our meter leads from the normal locations. And it's also when our meter is most vulnerable to damage. So I'm going to move my red meter lead from its normal voltage port over to the 10 amp fused port over here on the left. Then I'll put my meter in the 10 amp DC mode. On this meter, milliamps and the full 10 amps is on the same port. All right. Now, at this point, I need to be very careful how I go about connecting my leads. All right. This is just like a jumper cable at this point. And I wouldn't hook a jumper cable up from positive to negative on a battery. So the same rules apply with my multimeter from here on out. Any and all current's going to flow through this multimeter just like if it was a plain jumper lead. So you'd never hook up a jumper lead directly to a battery, it'd damage it. The same thing will happen with your multimeter when we have it set up like this. If I connect one of my meter leads to a point with voltage and the other lead to a point with ground, I'll blow the fuse in my multimeter or even damage the meter. One more thing. All of this circuit's current will be going through our meter, so we never want to connect into a high current circuit like cooling fans or power window motors to test current on those circuits. Since this car has so many features controlled by electronic control modules, I want to avoid disconnecting the battery if at all possible. Not only will I have to reset or reinitialize a lot of the modules, it's also going to cause some of the modules on the vehicle to stay awake, and that's going to make testing harder to do. We can see on the quick training guide that they address some of this. They tell us to lock the hood latch, so we're going to lock it with a Phillips head screwdriver here, and that's going to make sure the security system's able to power down properly. I'm also going to leave that screwdriver there just so I don't forget to unlock the latch before I shut the hood later. All right, so I've got my hood latched, I've got all my doors shut. And now I'm going to attach the negative clamp of my meter to the negative battery post, but I'm going to do it underneath that negative cable end, right? I've already loosened this cable just a little bit. I'm going to slide this open up those jaws and slide it in there without disconnecting power to this, all right? Now I'm going to hook up my positive meter lead and I'll go the other direction. We'll plug this in. I can go ahead and turn my meter onto DC current, and we can lift this cable off. That way we never break that connection. We never reset any modules. All right, and we've safely connected our meter. Now we can start our current testing we can start monitoring the amount of current going through here to help with our parasitic draw testing. So like the training guide mentions, it could take anywhere from 10 minutes to 2 hours for the vehicle to completely power down. This Camry, as you'll see in this quick time lapse, it took about 20 minutes to totally power down. Another thing to note is that vehicles with key off evap emission systems may power up a few hours after the vehicle is shut down to perform their self-test. So if you're monitoring this for a long period of time, you are going to see that on there. A lot of times I'll just have to check a known good vehicle to see what the normal draw is when everything is shut down. A general spec for maximum parasitic draw is 50 milliamps, but on some of our higher end vehicles like the Lexus LS line, we may see normal draw is quite a bit higher than that. Once you've established what a normal amount of current draw for your vehicle is, we'll compare our measurement that's made on the vehicle. So in this vehicle, it does look like we have some excessive current draw. I've checked quite a few other Camrys, and we should be very close or less than 50 milliamps because this model doesn't have very many advanced features. Now I need to work towards finding what's causing the parasitic draw. To do that, I'll remove the fuses one by one from the fuse box until the parasitic draw goes away. The parasitic draw should be on the circuit that caused my meter reading to drop the most. Now, pulling fuses is a great technique to help you find where the draw is coming from. But like we said at the beginning of this, I really want to avoid having those control modules resetting if I can. So another technique that we can take those clamps off of our meter, put our regular leads back on, and we can voltage drop test the fuses. So your multimeter's got to be set to the smallest range, so millivolts, or if you're in auto range, you're just going to have a little patience because it's kind of reaching the smaller limits of what you can measure. Now we have charts available to show what kind of current is normal for a typical circuit, but really you shouldn't see much more than 3 or 4 milliamps on a circuit if it's not supposed to be operating. And the way this works, well, we know every conductor has a little bit of resistance. So if we are passing current through one of these fuses, it's going to have some amount of voltage drop. The more voltage drop we show, the more current that fuse has flowing through it. All right, so once I know what fuse is powering my parasitic draw, I'll need to go about figuring where in the circuit our faults occurred. Toyota tells us disconnect various fuses, junction blocks, connectors, maybe even take a pin out of a connector until that current draw drops. Now that's a solid strategy, but I want to make sure I have a game plan when doing that. So let's look at the EWD and see if we can tell what this fuse powers. Well, it looks like it powers a lot of circuits, and that actually seems overwhelming, but I'm going to go ahead and start at the top of the list and see what this fuse powers. And here we see our fuse powers the main body ECU in this circuit. Next, I see that it also powers the main body ECU here. And again, in this circuit, it looks like the fuse that we had our largest draw on is powering the main body ECU. So at this point, I think we're starting to see a pattern. The main body ECU is listed in all these schematics, and it may be causing the draw in our vehicle. Now, why would the main body ECU be causing a high electrical draw? Well, if you think about something like your cell phone, it uses a lot more electricity if you were watching videos and surfing the internet on it all day versus if you just had it here at your toolbox. So our main body ECU has a lot of functions that it doesn't have to do all the time, right? It almost has a standby mode. So I suspect that maybe our main body ECU is being told to stay on, right? Maybe it's expecting some input from a customer, opening a door, using the security system, or something like that. Again, I think the tech stream is going to be my best tool to see what's going on there. So my health check just finished up, and I don't have any codes except one code from a tire pressure sensor. I don't think it's related to this one. I don't think it's the cause. So what I am going to do is go into the main body ECU, and I'm going to have a look at data list and see if there's anything in there that'll help me get some direction on this one. So once I get the tech stream connected, I'm going to hook them to the main body ECU, and we'll have a look at the data list for it. That's basically look at the inputs And it's kind of hard to make heads or tails from this at this point, but since we're at a dealership, it's really easy to go find another known good vehicle and compare the two lists. And what I saw when I did that was that the luggage courtesy switch should be off, just like all the other courtesy switches when the trunk door is closed. And on my vehicle, it's showing the luggage courtesy switch as on. So I need to figure out why my body ECU is getting an incorrect input from my luggage courtesy switch. Now I'm going to have one more look at that EWD. There was a lot of analysis on this one, but now I'm moving on to isolating the cause of this draw. I know the luggage courtesy switch circuit is responsible, so I'll have to analyze that circuit too. So looking at that circuit, it looks like the luggage compartment door lock assembly grounds that wire coming from the main body ECU. Now, since I have some knowledge about pull up and pull down circuits, and I'm going to put that on this diagram, I expect that I'm going to have some voltage at terminal 3 of my lock assembly when that switch is open. That'd be a really easy place to start. Connector TN1 would also be another useful test point, so I'll open up component detail and find out a little more about its location. And finally, I think the last test point that I would be able to use would be connector 3C terminal 9 at the main body ECU. We've been under the dash working in this area before, and that's not a lot of fun depending on what side that connector is on, so I'm going to put that one off until last. So I started my testing back here at T3, that's my lock assembly, and I thought I was going to have a pull down voltage on that wire, and I didn't see that. So notice my trunk light's on. I went ahead and disconnected T3, and that removes the path to ground for the body ECU, and the trunk light should go off, and I see that it's not. All right, so again, I've got 17 millivolts showing on my meter right now, so meter's not going to be a great tool on this portion of the circuit. We're almost doing the same kind of techniques we use doing short to ground testing, where I'm disconnecting different connectors and different pins and different components. All right, so I did go up through the EWD further up the line. This is the last place that this circuit would normally get ground. So I went up to TN1, and when I disconnect TN1, my trunk light goes off. All right, so that tells me that the short is between the portion of TN1, right? So I've got to look at my EWD real quick, and those are the female terminals. The short's between the female side of TN1 and my switch T3. Of course, I've got that graphic on here showing where on the EWD that is. So like most of the training center vehicles, it didn't take very long to find where the bug is installed in this vehicle. It's a short to ground near the female side of this TN1 connector. All right. Now, in real life, real scenario, the trunk area, there's a lot of cargo bouncing around here. There's a lot of heavy things thrown in and out. We're not very careful with it. And it's also susceptible to a little bit of moisture. So we do see failures back here in this area. Since this is a training center vehicle, all I had to do to repair the fault was flip that switch, and this vehicle is returned back to normal. Now I'm going to verify the repair by doing the same test that told me there was a problem in the first place, and that's that parasitic draw test. So I've got this hooked up now, and you can see on my meter screen here that our current draw is back at a normal level. So now this vehicle is properly repaired and ready to return back to the customer.